Hello and welcome to the fourth installment of Tutorial Tuesdays. Today is the introduction to procedural modeling, and what we're going to create is a building similar to this, maybe without all of the model detail because I'll let you all handle that on your own time. But what procedural modeling allows you to do is create one model that has parameters to it. So let's say we needed a neighborhood of mansions. Based on this one model, we can easily adjust the parameters like so, to create a bunch of different mansions. So what this technique is good for is for creating a bunch of different low resolution models that can go in the background. Like let's say you needed a bunch of different trees, or you needed a bunch of different but similar sculptures, or different tables, or different buildings. That's what procedural modeling is great for. It's also great for hard surface models. I would not use it for something organic necessarily. If you want to do more complex procedural modeling, I would highly recommend going to the side effects website and downloading the educational version of Houdini and playing with that. How I learned how to do this was actually in school, and we used Houdini. Houdini is a very complicated node-based modeling effects, and it's a really awesome tool for all sorts of stuff. But if you want to really get into procedural modeling, Blender was not designed for this, Houdini was. But you can get away with doing simple stuff like this in Blender. So let's get started. I want to create this mansion for the tutorial. How we're going to do that is first turn on our background images, add our reference, and grab the mansion. Now, the mansion that I'm using I found on Google Images by going into Google Images and typing in the word mansion, and this came up. I mean, a bunch of different things came up, but this one looked pretty easy to create. So we want this to be a little bit bigger, so I'm going to up the size, and we want this to be about on the x-axis right here on the ground plane. So our next step is to start matching it. We want to focus on just creating the first story because our procedural parameters are going to do the rest for us. So hit GZ1, having screencast keys and recording at the same time really messes up the latency of Blender. So you're going to see a lot of menus pop up that aren't supposed to pop up. So that creates our first story of the building. And probably about that wide is pretty good. Very cool. Then we want to add different stories to it. So we'll add modifier array. We'll put x to 0 and z to 1. So now we can up the stories of our object. And how we want to control this is with a controller object. The controller object will have all of our parameters on it that we can slide to update our individual model objects. So we'll add an empty cube, like so, and move it out of the way just so we can access it easily. So how this is going to affect the stories is very easy, but I'll show you that after we get the basics modeled out. So we're going to duplicate this cube, move it forward on the y-axis, scale it down. Right now I'm creating this white porch area. Move it so it matches the front of the house. We can model it like that. And then scale it down so it matches about the image. So something like that is pretty close. Great. So this is already looking like a house, isn't it? So how we're going to control the stories is with our controller object. Under the custom properties panel, under the objects panel, you can add a custom property, and let's call this one stories, just like so. And let's say we want the house to be able to go between 1 and 7, seems like a good number. You can make it anything you want. Your house can be 600 stories if you really want it to. Then under the property value, we're going to delete the 0 and the decimal because we want the user to be able to slide in integer values, not in decimal values. An integer is a whole number like 1, 2, 3, 4 without a decimal. Then we'll hit OK. So now our slider can slide between 1 and 7, which is exactly what we want. I'm going to go ahead and save this file just so we don't lose what we've already done. So under the array modifier, we will add a driver. Drivers allow you to drive different parameters of objects using sliders or custom properties. So under the graph editor, which is where you access your drivers, we're going to go to the drivers menu right here. We're going to hit this plus right here to open the properties, and we're going to select our count. We don't even need to see the graph for this, so we can actually expand this out a little bit, just so we can see all of the different numbers. So the stories are going to be equal to our parameter stories, so that is going to be right here under scripted expression. But to do the scripted expression with variables, we need to set some variables first. So our first one, var, you can add as many variables as you want for these expressions, but for this certain parameter, we only need one variable. So our object is going to be empty, since that is our controller object right here, and then single property. And how you access the custom properties that you build is you can actually just go here and copy data path, or you can type it in manually. I'll be typing it in manually for most of this, but I'm showing you how to copy paste at the beginning. So then we can say Control V, and that will paste in our stories that we copied the data path from. Then under this won't do anything yet because we haven't changed our scripted expression. So the scripted expression is the actual Python script or expression that changes the value of the object. So we'll just type var here because we want it to equal our stories. Then, as we slide this, you'll notice that our stories go up and down as we slide our stories, which is exactly what we wanted. So, under this guy's array, we will copy this by right-clicking and hitting C, then right-clicking this and hitting P to paste. Then this might or might not work. If it doesn't work, what you have to do is go under your thing and hit Update Dependencies. The Blender dependency graph is a little bit wonky and needs some work, but if you just update the dependencies, everything will work perfectly fine. Wow, we already have a mansion. This is beautiful. So I think our next step is going to be to add some windows. This is where it gets a little bit math intensive. So go ahead and pick up your high school math textbooks if you don't have them with you. No, I'm just kidding. The software can do most of the math for you. You just have to know what the equations are. So like I said, we're going to avoid doing any complex model detail for the meantime. We are just going to create the windows like this. And I forgot one thing actually. We want the width of this to be adjustable by this as well. So we're going to go ahead and add two properties here under our controller object. The first one is going to be the front width, which will control the building width. We want this to go between, let's say, 1 and 10 seems like a good number. The decimal place here is fine because we're not upping an integer value, we're upping a decimal value. We'll hit OK. Then the next property is going to be the porch width. This can go, let's say, between 1 and 5. That should be perfectly fine. So these two values are going to, the front width is going to adjust the building width, and the porch width is going to adjust the porch width. So what we're going to do is go under scale of this object, which is currently 1. Make sure that your scales are set by hitting Control A and scale to get it back down to 1. We'll add a single driver, and we will set this equal to empty, single property, open bracket, open quotation marks, and this will be front width, quotation marks, close bracket. This again won't affect anything until we update our scripted expression, so we'll go ahead and type our variable name into the scripted expression, which is var. You can set your variable name to be anything. I'm lazy, so I usually leave them at the defaults. So var. So now as we update the front width, that will work perfectly. However, we also want the front width to be based on the porch width. So the porch width is currently 2.356 and his width is 6.383. So our expression is actually going to be 6.383. Okay, I actually messed up. I am going to admit that. You can call me out on it, whatever. I messed up. We don't want to change the variable. Yeah, we do. Okay, yeah, we do. I think we do. I think we're in the exact right position. No, we're not. Okay, I'm sorry about that. So we're going to delete this driver, and we're actually going to update the dimensions of the object, which is completely indifferent to the scale. The dimensions are the actual Blender units of how wide the object is, which is what we want to update rather than the scale, which can be any dimensions and still be 1. So the dimensions are going to be the front porch. We're going to go ahead and name our objects just to be organized here. So front porch will be FP for front porch, and house front will be HF for house front. So under his width, we want this to be 6.383 minus the front porch dimensions. And how you access that is through FP, single property, and we aren't going to use the brackets here. We want to use this guy's dimensions. So First, we're going to get a set value for the house width, and that is 6.838 minus whatever the front porch width is, which is 2.356. So we'll do minus 2 point whatever his value was, which gets us down to this. But then we're going to add back in the front porch width, which will be whatever his dimensions are. So how we get that is by going to Object, Copy, Data Path, then Paste. That gives us dimensions. You'll notice that the box is still red, and that is because this just says dimensions. It doesn't say X dimensions, Y dimensions, or Z dimensions. So this whole block of data is actually an array, which is ARRAY, which is actually a list of multiple numbers. So in this case, it's 3 numbers. How you access different items in an array is with brackets. In this case, 0. 0 for X, 1 for Y, 2 for Z. Not 1, 2, 3, it's 0, 1, 2. A little bit confusing, I know. So we're going to add in the var that we just made, and that gets us back to our initial width. And we can make sure that that is correct by matching it up with the background image. So now as the front porch width changes, the house will change with it. And then we can add in another variable, which will be empty, and that will be front width was the name of our property. So then we'll add in plus var underscore 001. Okay, that's incorrect. We're doing dimensions, and we want the dimensions to be this times the variable underscore 001. So we'll put this all in parentheses. We don't want to add anything. So parentheses times var underscore 001. So times 1 is 0. Then we can up the front width, and now everything scales properly. Then if we scale this, you'll notice that it stays updated based on the porch width. So under the porch width's X dimensions, we'll just edit the scale because nothing is the front porch isn't based on anything. It's just based on the empty object. So we'll use scale instead of dimensions here. So we'll add a single driver, go to X scale, type in empty as our controller object, single property, and this one will be porch width, I believe, was our property. Then we'll type var here. So now we can up the porch width and that ups that, or we can up the front width and that ups that. Great. Now back to the windows. We're just going to use boxes at this point in time because you can add in the model detail later after you've gotten your house working, which we may or may not do in this tutorial based on how long the tutorial takes. So it looks like by default there are going to be 2 windows. So we'll add an array modifier, turn off relative offset. Okay, so this gets a little bit interesting. What relative offset does is it offsets it relative to the object's width. I'll show you right here. So if we change the width of the object, that changes the position of the array duplicate. However, constant offset bases it purely on Blender units, which is what we want for the windows. So if we offset this and then change the object, it doesn't offset the duplicate at all. So we want to be using constant offset because we want to base this on Blender units as opposed to the individual object. So the constant offset is going to be whatever it is to get to this window, which looks like it is going to be about 4. We'll just set it at 4, maybe 0.05. That seems about right. Cool. So if we increase the house width, you'll notice that nothing happens with the windows. And that is for a very good reason, because the count is not controlled by any sort of driver. So this is where we get a little bit math intensive. We want the count to increase by 1 every time the width of the building increases by 4.05. So how you do that is with a basic graph equation, which is y equals mx plus b. Missed my y. It's not hitting every keyboard stroke that I do because I'm recording and because of the screencast keys right here. So then, this equation, if we break it down into what we're working with, is going to be the count of the object is our y value. So we want the count of the object to equal the slope, which I'll get into the slope equation here in a second, times the variable, which is going to be the width of the house, plus however many extra windows we want, which is 1, because we want 2 windows total. So after the 1, we want 1 extra window before we start calculating the equation. So then how you actually set this up is going to be count. Oh my gosh, it is not taking in. Notice I hit C 5 times before it even showed up. That was quite obnoxious. So the slope equation is going to be basically 2 points on the graph subtracted. So our graph is going to, let's take points 2 and 1. So if the count equals 2 minus if the count equals 1, then over what those values are. So 2 is going to be, this value right here is what we want the building to increase by for our slope. So it's going to be 4.05000, but when the count is 2, we want that to actually be times 2. Then minus 4.05. Again, the keyboard is not responding every time I hit keys, which is quite annoying. So you could actually type in the value for this, but I'm just going to let the computer do all of the math for me. So this gives us our slope. So then we want this to be multiplied by our building width, which will just be var. However, we only care about half the building. We're going from 0 on the axis, so we only care about half the building. So it's going to be var divided by 2, then plus 1. Will give us the windows increasing properly. Actually, it will not. I lied. We still need to take this guy, our building width, and subtract the 4.05. And why that is because we only want everything that is not a window or the window offset to be included in the slope equation. Every time anything that is not the window or the offset increases by 4.05, we want to add a window. So that's why we're subtracting everything that is not just the building. Now, we also want to subtract the front porch, which will be minus var underscore 001 will be our front porch variable by default naming conventions, divided by 2 minus 4.0.5, which is now correct. So it's just taking in this small sliver of the building. Every time that increases by 4.05 due to our slope equation, we get another count on our array. So let's copy this equation and see if it works. Control C, we will add a driver. We will go to, we don't need the variables yet, we're just going to paste the equation, which is not going to work because we have no variables. So then we're going to add in our house, which is house front, single property, dimensions, and then x or 0. And then add a variable, var underscore 001, front porch, dimensions, x. So now, this should all work accordingly. So if we up the front width, we should be getting more counts, but we're not. And I'm actually perplexed as to why that is. Okay, I paused for a second and figured it out. The reason that it's not working properly is because our object scale is not correct. It needs to be 1, because the constant offset is now relative to this scale. Not to the dimensions, but to the scale. So the actual value that we want, let's delete this for a second, is going to be a lot less than 4. I apologize for that inconvenience right there, but I'm human, I make mistakes, especially when I'm recording tutorials. This is actually the second time that I'm recording this tutorial. So now we have the correct value. We'll just set this to 0.89, which should be pretty good. So now all of the values that were 4.05 need to be 0.89 because this will be correct. Minus 0.89 minus 0.89. Okay, so now if we were to copy this onto our count driver, everything should work. But again, we still have to set up the variables. So house front, single property, dimensions, x. See, the benefit of me doing this multiple times is that it will sink into your brain better, because everything is learned best through repetition. Dimensions 0. Great, so now as we increase the front width, it will increase the windows, but we subtracted the porch because now if we increase the porch width, the window count will not increase. If we did not subtract the porch, I'll show you what would happen. So I'll Control X just to keep that in my clipboard. You'll notice that if we increase the porch width, the count will increase because this guy's dimensions are increasing, which is why we are subtracting the porch width as part of our equation. So porch increase, front increase. However, you'll notice that the windows aren't matching the porch, and that is perfectly fine. We're about to fix that right now. How we're going to do that is to set the window's origin to be at the edge of this, and then base his x-coordinate off of this guy's width. So I'm going to say snap cursor to selected. We're going to go to Object, Transform, Origin to 3D Cursor. So now his actual position in space is based on this guy, or is equal to this guy. So to base it on that, we're going to go to the X location, add a single driver. X location, the variable will be based on the front porch, FP, single property, dimensions 0. Okay, so then if we type in var here, which is the name of our variable, you'll notice that it offsets. And the reason that is because right now it's offsetting the entire width of this object from 0 on the axis. So from 0 on the axis, we actually only want to offset by half of this guy's width. So we can do that just by dividing the dimensions by 2. And now it all stays perfect. So if we up the porch width, the windows follow. If we up the front width, that follows. If we up the stories, the windows do not follow, and we will do that next. We will add another array. Let's go ahead and turn our stories up to 3 just so we can make sure this is going to be proper. We'll change this to constant offset, and we will up it on the z-axis until it is about centered on the second story. So something like that is pretty good. And then we can copy, right-click C to copy, right-click P to paste. So now the stories script should do the same, update dependencies, and now as we up our stories, the windows are upped as well. Then to copy the windows, we can hit Alt-D. Alt-D creates an instance of the object rather than a duplicate. That means that they share the mesh data. So if we edit one of these objects, it will edit all of these objects, which is a lot more convenient when we're actually adding in the model detail. So to put him on the right, to flip him around, we're going to hit S, X, -1 to scale him on the x-axis by a factor of -1. That flips him. And then the x location, we're just going to multiply by -1. Since we're based on the center axis here, that should be exactly correct. So now if we go back to our properties, front width, that will up the amount of windows, perfect, and porch width will up that, and stories will up that. Everything is working phenomenally. Okay, now that we have our windows and our widths working properly, let's go ahead and create our roof. So to create the roof, we are going to add a new cube. Alt-G to put it to 0 on the XYZ axis, and then we can GZ1, again my keyboard is not being horribly responsive, and that will put him right at the origin at the base. Then what we're going to do is set his z-axis to always follow the top of the building. And how we do that is we add a single driver, and we're going to base this on house front, single property, dimensions, and not x this time. This time it's going to be the z-axis. So 0 for x, 1 for y, 2 for z. And then we're going to hit var here, and now the roof will follow this, even if we change the story amount. It will always follow the top, which is very cool. Now we're actually going to model out our roof. So bring this down. Let's go ahead and put our building up to 2 stories, just so we can get a good idea of how tall a roof should be. And then you'll notice that the roof actually overhangs a little bit here before the actual overhang. So we're going to add an edge loop, then add another edge loop. And we're going to scale the entire thing out until it's a little bit bigger than the building. And I think our building is probably a little bit too deep, but who cares? Maybe it's a big mansion. Maybe this family is super rich. Then we're going to take this and scale it down until the slope matches. And then we're going to scale it in until it's about triangular, but we're going to leave just a little bit of a plateau there. And that gives us our roof. However, if we scale the roof out, you'll notice that the side slopes actually increase in scale. And that is exactly what we do not want. So what we're going to do is add an edge loop right on the center, delete half of it, add a mirror modifier, add an edge loop, scale it down to 0, and move it over until it matches about here. Then we are going to separate this object. So P to separate, selection. So now this is a separate object, it's also being mirrored. We do not want that, so we'll go ahead and delete that. So then we want this guy's dimensions to be this guy's dimensions minus whatever this value here is, whatever both of these sides' values are. And how we get that value, let's go ahead and add on x dimensions driver. We only want one, so add single driver. Go over here to the x dimensions, and it says 3.548. Perfect. But we don't want that. We want this guy's dimensions to equal the dimensions of the house minus these empty spaces. So how we get that is, first of all, we find what the empty space value is. We don't actually have to do any math. The computer will do that for us. So we can hit Control C over this value right here. Make sure everything here is set to 1, just at our defaults before we do anything. Then we go into our expression, hit Control V. It did not copy properly at all. Great. So Control C. I'm going to do it a couple times just to make sure it copies. Come in here, Control. It is not copying. That is, oh, it's copying the actual expression. We just want 6.383. So we'll do 6.383 minus that, and that will give us the value of both of these edges added up. Then we say our variable is going to be minus that, and our variable is going to be the house front dimensions on the x-axis. So dimensions 0. So what's that saying is this guy's width is going to be, the roof's width is going to be the building's width minus whatever these were, because we did our arbitrary values right here. So now if we scale the building up, you'll notice that these areas right here stay exactly the same, which is exactly what we want. So to make this follow, we are going to change the center of the object, like so. So we're going to hit Snap Cursor to Selected, Object Transform Origin to 3D Cursor. So now this guy's origin is right here, so if we scale him, it's based on that point. Then we're going to set his X location to be another driver. Set that to be the roof middle. Let's go ahead and name this guy just for organization. RM for roof middle and RR for roof right. And we're going to set the roof right's X location to be roof middle, dimensions on the x-axis. So however wide this guy is how far this guy is going to be displaced by the x-axis. And you'll notice that that is too much. And again, that is because we only want to take half of the width, because it's coming from the center, not from way over here. Right now it's displacing him by this much. We want it to be displaced by this much. So we do that by dividing the variable by 2, just like so. So now his x location is going to match up with the roof's half width, which is perfect. Then we do the exact same thing for the other side. So we're going to Alt-D to duplicate this. Again, that creates an instance, so if we change the model, it will change both models. Then, under the x location, we change the variable to be times -1, and it will put him over here. However, he's still not facing the right way. We need to flip him on the x-axis. So we can do that by hitting SX -1. And that will flip him. And then just like that, now everything is working beautifully. And we have a house. So this tutorial is going a little bit longer than I would like, so let's just speed this up. I'm going to teach you all how to do the front of the house, like so, and then I might let you all handle the back all on your own just to see what you've learned. So now we're going to approach the front porch overhang, which is this triangle right here. So let's go ahead and create that. First things first, let's set the origin to be at the base, so GZ1. Then we're going to set his location to be exactly the same as the roof. So we're going to copy driver and paste driver. And since that did not take, we're going to click on it and hit update dependencies. So now the front overhang will match the stories as well, which is exactly what we want. Now we can actually model him. So we want his height to be about the same as the roof. We're going to write an expression for that later, but just for the meantime, we are going to set it. Then we want this to be right there, so now if we scale it, it's based on the center. Then we're going to move this out until it looks about right. So somewhere maybe about like there for our front porch seems pretty good to me. Then we're going to select the top vertices and scale them on the x-axis down to 0, hit space, and type remove doubles. And that will get rid of the extra overlapping vertices, so we only have one vertex here. Then you can also model in some triangular detail here if you want to. I am choosing not to, just to speed up this tutorial. This is all about expressions. This tutorial is not about modeling. Go find a modeling tutorial if you want to learn how to model. So we will actually move the triangle piece up here. And we're going to match his x dimensions to be equal to the porch. And how we do that is change the x dimensions, add a single driver. I hit Z, I did not hit X. X dimensions, add a single driver, single property, and this is going to be for the front porch, or FP. And this will be dimensions X, or 0. And then var. And now, regardless of how big we make the porch width, it will always match, which is exactly what we want. But we actually want this triangle to overhang a little bit from the porch width. So what we can do to our variable is add an arbitrary value like 0.2 or maybe 0.3. And now the roof will actually overhang a little bit, which is exactly what we kind of want. Because then we can come in here and add our extrusion here and scale it down to match the porch width. And maybe add a little bit of model detail. I said I wouldn't, but I am a perfectionist. So that gives us our roof. And if we scale everything out, everything still works. Porch width, stories, front width, everything is perfect. Great. So now we want to create these columns. And we want the columns to match up with the roof. And how we do that is we add a cylinder. Let's do 16 vertices. That's pretty good. We can scale it down to match the column. Notice that this actually is in further on ours than it is on the image, so we're going to compensate for that right here. We are going to select these, hit snap cursor to selected, object transform, origin to 3D cursor, move him down to 0, 0, 0. From the above view, we can move him here, move him over, and then we can say that his z dimensions will equal the dimensions of the front of the house. So we can say house front, single property, dimensions, 2 for z, and then var. So now the column will always match height with the building. So if we up the stories, the column will match, which is exactly what we want. That is beautiful. Then we can not duplicate him. We want to make another array. So we'll do an array modifier. And we will turn off relative offset and change the constant offset. Again, we want the scale to be set to 1 because otherwise the constant offset will be incorrect. And then we want to put this over to about the edge here, like so, which is great. That gives us 2 beautiful columns. Scale, scale, shift Z to scale on everything except the Z-axis. I want these to actually be a little bit thinner. And then we're going to use the exact same slope equation that we used for the windows. So we can actually just go ahead and copy this and paste it. Of course, we have to modify it. First things first, we don't have to subtract var underscore 001 anymore because this is based purely on the front porch width, not based on the house and the front porch width. Then we want our slope to be based on this value, which let's go ahead and just set this to 0.56 to get a nice round value. Then we can change everything that's 0.89 to 0.56 because this is our new slope value. We want the +1 to stay in place because we have 2 columns to start out with, and we want our variable to be the porch width, so front porch as opposed to house front. So now if we up the porch width, you'll notice that the columns increase with it, which is exactly what we want, and that is beautiful. So I will hit Alt-D to duplicate this guy right here, minus for the x location to put him exactly in the opposite direction. Then we will change the constant offset to a negative value. So now if we up the porch width, these will increase, and if we up the front width, that will increase up the stories. Everything still works beautifully. So that is the basics of procedural modeling that you really need to know. I can go into more detail, but this tutorial is already running 35 minutes in length. So you know what, I'm going to go ahead and add the back, and I'll leave adding the windows and such on the back up to you. So how we add the back is we are going to duplicate the front and move it until it matches. Actually, you know what? Just for the sake of keeping this tutorial short, I will let you figure that out. However, I will tell you that the back is the exact same equation as the front, but instead of subtracting the porch value, you subtract the building value and change the arbitrary values to whatever you want to make the width the same. Let's move into procedural texturing because that is more valuable information since you already know the basics of everything that you could possibly need to know to make a procedural house in Blender right now, or this mansion specifically. There are more complicated houses, but this is an intro to procedural modeling. This is not a complicated tutorial. So how we're going to approach the textures is, you'll notice if we unwrap it and texture it, then the textures will stretch when the object stretches, and that is exactly what we do not want. So let's go into Material View. I'm going to go ahead and save. You need to save in iterations and save frequently, because otherwise you are going to lose stuff when the software crashes. So the texture is going to be a brick texture. So under Material, we'll use Nodes. Then we will go to our node editor. And we will add a texture, image texture, open. I found my bricks on cgtextures.com. You can feel free to do the exact same thing. So under Material View, you will notice that it is not doing anything yet. And that is because we don't have any UVs. So we will go ahead and reset the UVs. But now it's all incorrect. And watch, if I increase the width under our custom properties like so, you'll notice that the bricks just stretch, which is exactly what we do not want. So how we fix that is by projecting the textures instead. And we do that with cameras, lots and lots of cameras. So we'll add a camera. Alt-G, Alt-R to reset rotation and location. We will rotate it to face the building, and we will make it an orthographic camera, so it's projecting straight on with no perspective. Then we come over here, and we add a UV project modifier. We want to add it after the array modifier, because then it will project the UVs including the array, as opposed to just the object before the array. So our projector is going to do whatever this camera is called. Let's call it front proj for front project. So front proj will be our projector, and now you'll notice if we move the camera, this will stay correct, and if we up the width, the bricks will stay in place and we'll just add more, which is exactly what we do want. So you'll notice that the sides are stretched, which is again is exactly what we do not want. But under the projection, you'll notice you can add as many projectors as you want. So we're going to add one for each side, and I'll tell you why we're not just doing two here in a second. So we'll add the second projector. This will be right proj. So if we add this one in, right proj, then it will project onto the side. But now that will be incorrect because it does whatever faces are closest to it. So this is currently doing that face and that face, or closest to the angle. So this is currently doing that face and that face, which is why we need 4 cameras, one for the front, one for the side, one for the back. So we will duplicate this, rotate it 180 degrees, and we will name this one back proj. Then we will duplicate it, rotate it negative 90 degrees, move it over here, and call it left proj for left project. Then we will add these back proj and left proj to our thing. And now, no matter what we do, since these are orthographic, this will not change in width unless we change the orthographic scale of this, like so. So there are a couple ways you can change the size of the bricks now. You can change the orthographic scale, or you can change it in the texture properties. I prefer to change it in the texture properties because it's less tedious. So we go to input texture coordinate, we want to use UV. Then we go to we go to vector mapping, and we shove this right between our texture coordinate. Then we can up this to 12 by 12 by 12, and now we have a ton of bricks. They're so small, this looks like a giant house now. Very cool. So that is how you do procedural textures. Now the roof, you'll notice, is at an angle. So how would you approach that? That's actually very easy. So you do the exact same thing, UV project. Let's go ahead and add a new material. We'll call this one shingles. And under the materials, we will add a texture, image texture, and shove it in like that. And this one will be a shingles texture, or roof tiles, that I found on, again, CG Textures. So notice that nothing is showing up. That's because nothing is unwrapped. So we will reset the UV coordinates. And that looks pretty decent, but it's still not quite correct. So, and it will stretch if the roof stretches. So we'll duplicate our camera. We will make its rotation match the slope of the roof just about. It doesn't have to be perfect, like so. And then this will be front R project for front roof project. We'll go back into the material view, and we will change this to front R project. So now if we move this, that will update all of it. But we want this tiles to be facing the other way on the other side of the roof. So we'll duplicate this, rotate it 180 degrees, move it over here, and then we will call this one back R project. And we will add that right here. So we will add another projector, back R project. Back R project. Okay. So now this is affecting the back, this is affecting the front. Nobody is going to see the center part. You can add a center piece of mesh there to cover it if you want. But if we scale the house up, then everything will be perfect. Okay, so there's one more trick that I really want to show you before I call the tutorial quits, and that has to do with what if you want different windows on different stories. So let's say we have 4 stories, and we want the windows to alternate. So let's say that these windows, so let's say the second story windows are going to be like wider, weird windows like that. How would we approach that? So how we do that is we change the stories count, which I believe is 001, yep, stories, and this will be, the count will equal this divided by 2. So now we only have these windows on 2 of the stories, and then we just multiply our constant offset by 2. So now this window will only go on every other story, like so. But we might want to do, okay, so you'll notice that it's not showing up until 1 story later. And how you fix that is you just add 1 to the count. So var plus 1 divided by 2. This has to go in parentheses because of the order of operations. So now, every other story, these windows will show up. And then, to do these windows, we do the exact same thing. Except this will be var minus 1 divided by 2. Or actually, it might just be var divided by 2. I'm affecting the wrong thing. Okay, so count var divided by 2 minus 1. And multiply this by 2. No, I think it's just var divided by 2, and that will be correct. Yeah, okay, that makes sense. So, but then you'll notice if we go below that story that this will still be there, which is exactly what we do not want. So how you can fix that is if you take this and you will make a driver for its visibility. We're going to start with the render visibility to make sure it works, then go to the viewport visibility. So right click, add driver, and for this, 1 is off, you'll notice, and 0 is on. So how you do if statements is we're going to make a variable. This will be empty single property stories, like so. So how you do an if statement is you say var, you can do less than, equal, does not equal, all sorts of different programming signs here. But we're going to see if var is less than 2, then this will be binary on. It's a Boolean switch, 0 or 1. If this is true, then it will be 1. If it's false, then it will be 0. Again, 1 turns it off, which doesn't make sense to me, but 1 turns it off. So now, if the stories are less than 2, the object will turn off. So then we just have to copy this driver and paste it, and update the dependencies, of course. So now it disappears unless the stories are greater than 1, or are not less than 2. And that's how you would offset different windows for different stories. And you can do that for as many different ones as you want, really. You can do 3 different kinds of windows, 4 different kinds of windows. That is all up to you. Then, just a few tying loose ends things here. I approached this part of the building the exact same way as I approached the windows. I modeled this out, did an array modifier, and based it on the back's width, minus half of this guy's width, minus half of this guy's width, minus whatever the offset for this was. And that gave me that. It's exactly the same as the windows, and then the rest of this didn't scale. These windows were just glued to the center of this guy. So we are at 45 minutes. I think that that is a pretty good place to end this tutorial. How you would finish texturing the roof is you would do the exact same. I'll just do it for you right now. You would add the shingles texture, reset, then add a modifier, UV project, and we also want the roof sides for this. So we will duplicate this, rotate it like that, and match the slope of the sides. And this will be roof right project. We don't want to add it to a group. That was all wrong. Right rproj. And then the other one will be left rproj. Like so. Then we go back to our materials and we add our projectors. Front rproj. Right rproj, back rproj, and left rproj. And then we can select this guy, hold shift, select this guy, control L, materials, oh not materials, control L, modifiers. It will copy his modifier over here. So now you'll notice that these are projected all properly, except this guy is still based on this guy, and that's because he is scaled negatively on the x-axis, and his mesh is based on this guy. So what we can do here is hit this 2 to make him a single user, and we can apply the scale and flip the normals. You can go into edit mode, hit Control N to reset the normals, and now all of the projectors are correct. And then to make the shingle smaller, we can do the exact same thing where we input the texture coordinate UV and put the vector mapping up to 12, 12, 12. Probably maybe like 666. Oh my god, 777, just so I don't offend any religious people. Okay, and that is how I would do procedural texturing on the procedural modeling. So notice that the roof textures are all staying in place, which is exactly, again, what we want. So, and then you can go in, you can add window models, and it will and since we did an Alt-D, it will even update these. So if we made a window here, I'm getting a little bit disorganized here towards the end because the tutorial is already technically supposed to be over. As many windows as we want. Select all of these faces. Inset, eyes inset, and then turn off border, or individual we turn on, change the thickness, something like that, then select outer and extrude those in. And now instantly we have a bunch of windows. So that's how easy it is to add model detail to your procedural building. So I think I'm going to call the tutorial quits there because we're already getting near an hour. Hopefully you learned some neat things, how to make driver-driven models using a control object, like so, which is pretty cool. You can add windows to the porch. You can do whatever you want now that you understand how to do this, and that adding windows and stuff is literally just a simple algebraic slope equation. It's very basic math stuff. The software does most of it for you. And it's a really cool thing to be able to do, like if you need a neighborhood of mansions. And this isn't just useful for making houses. You could make a room full of different tables with different numbers of legs. You could make a sculpture. You can make a spiral staircase. You can do really anything your imagination will let you do. And I might do future tutorials on different techniques. But For the meantime, I'm going to call it quits here. I think that will suffice as a decent introduction to procedural modeling in Blender. I hope you enjoyed this tutorial. I hope you learned something. If you want more tutorials every Tuesday, make sure you subscribe. I'm going to call it quits right there. Have a fantastic day, night, or whatever time it is for you.